valve to release any trapped air. Never run the pump dry because the rubber stator will get damaged quickly. For the last point, oil must be touching before run the pump. So, crude palm oil is thick, especially when the temperature is low. So, for the first point, the oil is too cool. The suction pipe is too small. The suction pipe is too long. And for the last one, there is air leakage at 3 clamp joints. For cavitation happen when the pump is trying to suck oil faster than the oil can flow in. When that happen, tiny bubble form and then explode inside the pump causing. So it can make vibration or damage to rotor and stator. Okay, so for the next one is control and monitoring method. So the first one is mechanism, which is the control the motor's operating frequency, which is directly adjust the pump rotational speed. For throttling valve, adjust the valve opening, creating artificial resistance on the discharge line. For the second one is efficiency. High efficiency power consumption varies with the cube of the speed reduction. Low efficiency wastes energy by forcing the pump to work at full speed and then dissipating excess power as heat across the valve. For the proportionality, flow is linear with speed. Flow is non-linear and depends on the valve trim and system pressure. For the last one is wear. Low wear, running the pump slower, reduce wear on the rotor and stator, extending pump life. For the high wear, increased pressure can stress component. The valve itself is subject to high erosion and cavitation, so it can wear from pressure drop.
So next we continue to how to calculate the pressure loss of the system pump for pump oil. So first, before we calculate, we need to search their information. How first is density 920 kg per meter square. Second, flow rate 5 meter cube over hour. Diameter of pipe 0.15 meter. Viscosity 0.01. Number of elbow 7. Pipe length 50 meter. Valve of elbow 5.1 times 7 and 1.5 times 7, and pipe roughness 4.5 times 10 to the power negative 5. Next is a fully open valve, 6 inch 7. The 7 is the volume of the valve, and the suction of the pump is a 6.06. And the head of the pump is a 266. So next we continue how to calculate. We follow step by step. So step 1, we change the unit to the SI unit to m cube per second. So we just 5 cube times 1 over 3600 second, and we got 0.0014. So step 2, we find the area. So pi times the diameter of power of 2 over 4. So we get 0.0177. So next is step 3, we find the velocity. So we use the formula V equal to Q over area. So we in the information from previous and we get 0.7130 meter per second. And for step 4, we search their Reynolds number. So we use the formula PVD over mu. So we in the information and we get the knot value is a 9839.4. This is a value of Reynolds number and the type of the flow is a turbulent. So next, step 5, we find their measure. So we need to use their formula to find their measure. So this is the formula to find the measure. So F, we use this formula, this not combined, and this is a formula for this. And after we in the information of the data, we get the value of the measure number is 4.8460 times 10 to the power negative 3. And next, step 6, we find their minor. So we use this formula and we just in the information from previous and we get 0.0326. And after we get this information, we need to calculate their K. So the formula of the K is n number of elbow times value of elbow plus number of valve times value of the valve. And we in the information and we get 5.2552.5. And after we get this and we need to calculate just into the formula and we get 0.062. And after we get the all information, we can find the total head loss. The formula the total head loss is a major times minor. So we in the information and we get 0.066846. So the last step, we search their pressure by use the formula rho GH, the formula of the pressure. And from information, the answer we get is 603.30. So from the all of the calculation, we can conclude the pump is suitable and can running without any problem.
Okay, for the conclusion, based on our team, is the pumping system was designed using a progressive cavity pump due to its ability to handle high viscosity, crude pump oil gently and efficiently, supported by SS316 or SS316L, piping and globe ball valve that provide strong corrosion resistance and reliable flow control. Proper priming and cavitation prevention were emphasized to protect the rotor and stator, especially by maintaining oil temperature, ensuring airtight suction, and operating the pump at suitable speed. Pressure and flow monitoring instrument along with VFD speed control ensure stable system performance and safe operation. This project demonstrates the importance of matching pump selection, piping material, operating condition and control strategy to the characteristic of the fluid being transferred. So that's all from me. Thank you.
Dah good, Rick.
Duduk jauh kat hari ni.